Hey everyone, in this AP Chem series video, I'll explain what we mean by the term successive ionization energy values. First, let's remember that ionization energy itself is simply the energy required to remove an electron from an atom. We can model that with this carbon atom by removing an outermost electron, turning it to a +1 cation, and measuring the amount of energy it took to remove that electron. To save time, we often model this process with an equation that shows the original atom, in this case carbon, the energy required to remove the electron. The atom changes to a +1 cation and the electron that has been separated and removed. In this video, we'll take a look at what would happen if you removed that first electron, but then kept on removing more. And this is what we mean by successive ionization energies. It's the energy required to remove one electron after another from the exact same atom. So we've already modeled this process to remove the first electron and get the first ionization energy. What would happen if you then tried to remove a second electron from this +1 carbon? It would look something like this, removing another electron from that outermost shell. The atom would change now to a +2 cation since we've removed 2 total electrons, and the reaction would look like this, showing the +1 carbon we started with, the energy required to remove that second electron, and the +2 carbon that it changes into, as well as the second electron that's been removed. This quantity of energy would be referred to as the second ionization energy. And you can keep doing this for as many electrons as the atom has. Here we'll do one more and show the third ionization energy by removing a third electron, changing the atom to a +3 cation. The reaction would show the +2 carbon we started with, the +3 carbon it changes into, and this quantity of energy would be the third ionization energy value. Being able to write out this series of successive equations is definitely one of the key ideas for this video. Make sure you've paused and taken a minute to write those down. We can also start to take a look at some of the general differences between the amount of energy it takes to remove one electron after another. I'll show you that by putting in the exact amounts of energy required to remove the electrons here from this carbon atom. The first, 1086, 2300, and 4600. You should notice right away that more energy is required to remove each successive electron. We can explain why that is by looking at the 3 models shown below. The removal of the first electron, which we'll show here on the blue atom, is the easiest one to do. It takes the least amount of energy. That's because this electron is attracted to the positive nucleus of the carbon, so it takes some small amount of energy to break it free from that attraction. It takes more energy to remove the second electron because not only is that electron attracted to the nucleus of the carbon, but the attraction is stronger because now the entire carbon atom also has a +1 charge. And that increased charge magnitude results in a stronger attraction and requires more energy for the electron to be removed. And that effect continues if you imagine trying to remove an electron from a carbon atom that now has a +2 charge that has the largest charge magnitude, so it would have the strongest attraction and the most energy would be required to remove it. We can summarize these differences by saying that more energy is required to remove each successive electron because a stronger attraction exists between the electron and the atom as the atom becomes more positive. That's another one of our key ideas for the video. Make sure you take some time to write it down. That also wraps up this introduction to successive ionization energies. Thanks a lot for watching, and here's a brief summary.